This means that we are working in the perfect condition, normally outside the safe operating area, but outside the linear region. So we can deliver the maximum design power ideally if all the MOSFET are well connected, and also the transitory of 1000 ampere for each one can be reached easily. In this slide I show you the final test. I decided to put 2 layers of nickel strip because the bottom layer simulates the battery surface. So if it is connected, means that the copper sheet is perfectly soldered to the surface of the battery. Taking off the lower layer, you can see the good connection, so the spot welder works fine. This is the final construction of my spot welder. This is the side of the battery. This other side is the spot welder pen connection. The potentiometer is shown here, and the power on off is represented by the switch. The pulse frequency is regulated by another potentiometer placed here that is not visible. The enable trigger input switch is this connection, and then the wire goes up to the spot welder pen where is placed the switch, and I enable the pulse. You see the cable of the switch. This is my battery pack. Since my battery pack is designed to deliver more than 1 kilowatt, and the 48 volts of the battery pack under load will be less, I think 36 volt or even less. When you provide this power, less voltage of the battery means higher current output. With 0.1 mm of thickness I can reach 20 amperes. This means that at least another layer of copper I need to place over it. So I decided to solder in 2 stages the connection. In the first stage I use a nickel plated strip with 0.1 mm copper sheet over the battery electrode. Then in the second soldering stage I used the same nickel plated steel with 0.1 mm copper. With 2 layers I can reach the design current. Ecco, è partito. In this other slide, I would like to underline why sometimes the spot welder doesn't work properly. I decided to put the oscilloscope between these 2 points shown in this picture, namely 1 side, the positive of the battery, and the other side is the positive of the input in the spot welder case. So between these 2 points there is a cable of 16 millimeter square, and the length is about 0.7 meter. I registered the pulse with 20 microseconds per division, and the result is this one. More than 3 volts of dropout across the cable. This means if you know the cable surface, the conductivity of the copper, you can calculate more than 1000 of ampere. So in this point you have 1400 amperes, more or less 1000 here. But if you know the total length, you can calculate more or less 8 volts of dropout in all the cables. If you estimate, because I also register the voltage here, so if you estimate 10 volts of the power source, you can easily know that 80% of the energy, total energy delivered from the source is wasted in the cable. So this result is not so good. I didn't buy a new cable at the moment because I've decided to follow another route to construct my batteries, but I can think this is an important point to know before the construction. Conclusions. All in all, the new design of the spot welder is very good in terms of reliability. I did a lot of weldings, but the result is better than in the past, and the spot welder never failed. The trigger switch placed in the spot welder pen is very comfortable, and you can decide exactly when the current flows, and is a good achievement. As we have seen before, the cable size of 16 mm square is too small to use it for copper nickel sandwich method. So for better results you have to shift with 25 or even 35 mm square at least for 2 meter of cable total length. Regarding the plastic case, you need to place the high power connector panel. Otherwise, if you torque the cable or stretch the cable, this mechanical stress is transferred inside the copper bar where the MOSFETs are attached, and you can damage the board. So take care of using an high power connector, and I bought recently it, and I'm going to install in my board. The nickel copper strip must be very clean and no oxidation or grease on it. So you need to use the gloves, otherwise the grease on your finger will be attached on the surface of the copper, and the result is very poor. I tried many times with the battery pack to solder the surface, and if the surface is very clean, you have 10 times more possibilities to get a reliable weld. High power source is needed for the copper layer. Yes, you have seen 1400 amperes are not enough, in my opinion, to solder 0.1 millimeter of copper. You need to use at least 2000 of ampere, or using for example greater sides of the copper cable. In any case, I will do another video in the future where I recorded all the current transitory to know better what is happening inside the soldering and understand better the physical behavior of the whole system for other future design or just for curiosity. So thanks for watching.